Hello guys, today we are going to be talking about circles, the equation for the area of a circle, and the equation for the circumference of a circle, and chords and tangents. So the circumference of a circle is the distance around a circle, and the distance across a circle through its center is called the diameter, and half the diameter is the radius. So the equation for the circumference of a circle is known to be d times pi, which is diameter times pi. And for the area of a circle, it is r squared times pi, which is radius times pi. So right below here, we have a sample problem, which gives us a circle with a radius of 6 inches. And the problem asks us to find the area and circumference of this circle. So, as we know, the radius is 6 inches, which means the diameter would be 12 inches because radius is 1/2 of the diameter. So, if you multiply the radius by 2, you get 12. So, the area first. To find the area, you just take 6, square that, which would be 36, and then you multiply that by pi, and then it gives us 113.097 inches squared. So for the circumference, we have a diameter of 12, multiply that by pi, and then we get the circumference to be 37.699 inches. So we're going to move on to chords. So for a chord is a line segment connecting two parts which lie on the circle, or 2 points, sorry. And then right below, we're given a sample problem with the radius of 8 inches, and we have a chord of an unknown length that is drawn from point A to point B, and we are also given that the arc measure for this chord is going to be 60 degrees. So right off the bat, we know that the central angle for this arc measure is 60 degrees because central angle equals the arc measure. And then right here, we take a line down or an angle bisector that also bisects the chord, which gives us a 30-degree angle on both sides, and then we end up having a 30, 60, 90-degree triangle. So then to find segment AB, or the chord AB, we just do sine 30 equals 1/2 AB over 8. And then that ends up balancing out to 1/2 AB equals sine 30 times 8, and then we find AB to be sine 30 times 16, and then AB equals 8 inches. Next, we will be moving on to tangents of a circle. It is a line that touches the circle at one point, which is known as the point of tangency. So once again, we have another example problem, except this time we're given a circle with radius 3. And then we can see that a tangent is drawn, tangent DC is drawn to the circle, and the point of tangency is going to be point A. So we're given that segment BC is 2, and then we know that the radius of the circle is 3, so MA would be 3, and MB would also be 3. So then right off the bat, we're trying to find AC, so we already know that this is a right triangle because the center of the circle drawn to a point tangent is always going to be a right triangle. So right off the bat, we have a leg and a hypotenuse, so we can do Pythagorean theorem. So MC would be the hypotenuse, and then that would be 5, and then the leg MA would be 3. So we're solving for AC here. So we can do 5 squared equals 3 squared plus x squared, which is AC. So AC squared equals 25 minus 9, and then AC squared equals 16, and AC ends up being 4 inches. Alright guys, thank you for listening. I'm Alex. Have a good day.